There, what is up, YouTube? This is Nitty. Again, another video about B-complex vitamins, no doubt. Actually, it's a little bit more than that, I think we've gotten fitness science wrong. Like diets are, there's just an outdated term. Should you focus on being anabolic or catabolic, for example, right? Look, diets may be useful. They may be a useful tool, but they can really hinder your performance and your goals if you're uninformed, right? So I'm currently working on a video on diamine oxidase, and I'm discovering that there is an essential B-complex vitamin needed for its metabolism, right? If you don't know what it is, diamine oxidase helps to metabolize histamine in the body. So anyway, on my way to the library, so to speak, I am finding out a lot about nutrients that we commonly miss. Wow, it seems like everybody's sleeping on these B-complex vitamins. In my research, finding out that B-complex vitamins are pretty essential for most of the stuff that we have problems with. So, for example, if by consuming meat or fat you experience inflammation, well, it just might be that you have insufficient amounts of B vitamins in your system. B vitamins are coenzymes, by the way. It's that simple. I mean, if you're under 25 and you can consume carbohydrates with no ill effects, then it's probably because of all those years of eating breakfast cereals fortified with B vitamins, for example. B vitamins are essential for consuming and metabolizing carbohydrates, right? Well, anyway, I say all of that to say this video is about vitamin B2, mTOR, and my ebook, The Ketogenic Advantage Blueprint, right? And I wanted to know all about vitamin B, so I asked my friendly Chat GPT-enabled up a couple questions. And this is what I got about vitamin B2. So, there are eight B-complex vitamins, as we talked about before, and vitamin B2 is pronounced riboflavin, right? So vitamin B2 is also known as riboflavin. It's a water-soluble vitamin that plays an important role in the body's energy production, as well as in the metabolism of fats, carbohydrates, and proteins, right? It is also involved in the maintenance of healthy skin, eyes, and nervous system. I know B vitamins are responsible for how our body produces energy, so I asked the question to describe the mechanisms that support vitamin B2's role in energy production in the human body. Vitamin B2, also known as riboflavin, plays a crucial role in the body's energy production by serving as a cofactor for enzymes involved in the electron transport chain, which generates ATP, adenosine triphosphate, the body's primary source of energy. Riboflavin is also involved in the metabolism of other B vitamins, such as niacin, pyridoxine, which are also important. I'm like, what? Really? Describe the mechanism by which vitamin B2 is involved in the metabolism of the B vitamins, right? Say relevant sources in relay format. So I want to know how B-complex vitamins contribute to catabolic processes, right? Cite relevant sources in relay format. B-complex vitamins, including thiamine, riboflavin, niacin, pinoleic acid, pyridoxine, biotin, folate, and cobalamin play important roles in catabolic processes by serving as cofactors for enzymes that involved in the breakdown of macronutrients such as carbohydrates, fats, and proteins into energy. For example, thiamine, riboflavin, and niacin are involved in the metabolism of carbohydrates, while pinoleic acid and biotin are involved in the metabolism of fats. Pyridoxine, folate, and cobalamin are involved in the metabolism of acids and building blocks of protein. What if you're fasting, right? So I wrote this book called The Ketogenic Advantage Blueprint. Some of its processes and some of its steps lead you to a point where you can fast relatively easily. And so I wanted to know how B-complex vitamins might contribute to anabolic processes. So I wanted to know how B-complex vitamins might contribute to anabolic processes. And since B-complex vitamins, including thiamine, riboflavin, niacin, pinoleic acid, pyridoxine, biotin, folate, and cobalamin play important roles in anabolic processes by serving as cofactors for enzymes involved in the synthesis of macromolecules such as DNA, RNA, and proteins. For example, folate and cobalamin are involved in the synthesis of DNA, while pyridoxine is involved in the synthesis of neurotransmitters and hemoglobin. Interesting, right? So if you're short in pyridoxine, you can have issues with hemoglobin. Interesting. I started to think, when someone is in ketosis, is their body in a state that is primarily anabolic or catabolic? Cite relevant sources in analytic format. And when someone's in ketosis, their body is in a state that is primarily catabolic. In ketosis, their body relies on a breakdown of fat for energy, which involves the process of beta oxidation. Beta oxidation is a catabolic process that breaks down fatty acids into acetyl-CoA, which can be used to produce ATP, the body's primary source for energy. That study is from 2006 and 2014. These two studies from 06 and 14. So then I went on to ask, I was like, I see something interesting here. So when someone has mTOR activated, is their body in a state that is primarily anabolic or catabolic? When someone has mTOR activated, their body is in a state that is primarily anabolic. Their body is in a state that is primarily anabolic. mTOR is a protein kinase that plays a key role in regulating cell growth, proliferation, and metabolism. Activation of mTOR promotes protein synthesis and inhibits protein degradation, leading to an overall increase in the anabolic process. And the sources here are from 2017 and 2012, a little bit more recent, right? And then my final question I need to know, is it possible to be in ketosis and have mTOR activated simultaneously? See what I did there? Cite relevant sources in the analytic format. Yes, it is possible to be in ketosis and have mTOR activated simultaneously. While ketosis is primarily a catabolic state, mTOR activation is associated with anabolic process. However, recent research suggests that mTOR activation can occur in response to specific nutrients such as amino acids, rather than simply in response to overall energy intake. Interesting. This means that it is possible to have mTOR activated in the presence of low glucose and insulin levels, which are characteristic of ketosis. And these sources are from 2017 and 2017. So there you have it. So some of the studies suggest over years that eating meat is bad for us, and that it causes us to be inflamed. A solution is that, well, in any of these studies, can we look back and see that people have sufficient levels of B vitamins when they're doing them? Because you can imagine if they had insufficient levels of B vitamins when they're consuming meat for the study, that it could skew the results one way and cause someone not to eat meat anymore. Or milk, for example, right? So if milk is a protein that you can't digest, you don't have B complex vitamins needed to metabolize some of the fats and proteins in milk, are you going to have an issue? Yes, right? Yes. If you have insufficient levels of B vitamins. There's one thing though, I should caveat this video by saying B vitamins can be catabolic or anabolic, which is I learned today. They can also be inflammatory or anti-inflammatory depending on the context, right? And so there are coenzymes, and I typically always take them, if I take them at all, with food. And I always have to eat food with B vitamins in order to feel like okay, right? Anyway, that's it for this video. If you want help reaching your fitness goals, seek a fitness performance professional. If you want help reaching your wellness goals, do the same. If you want help from me, there's resources in this video, there's resources on the YouTube channel at iHeartNews. I'm Smitty. I help you reach your fitness goals, and I'll talk to you later.